Okay, let's give you guys another example. So in this video, we're going to use the ratio test to determine if this series will converge or if this will diverge. So to do this, we need to get an plus 1 divided by an. So looking at this, an plus 1. Well, looking at this here will be an plus 1. This is an plus 1, and then this here will be an. So to obtain this, to obtain the next term, we would put n plus 1 into the n here. So that would be n plus 1 factorial, and then we would put n plus 1 into here. So that would then give us n plus 1, and then we would need to put n plus 1 into the n here. That would then give us this. So this is our an plus 1, an plus 1. This is our an. This here is our an. So now looking at this, we need to glance at this. We need to glance at this. So remember, n is moving from 1 to infinity. N is moving from 1 to infinity. N is moving from 1 to infinity. Well, when n moves from 1 to infinity, n plus 1 factorial will be positive. This thing here will be positive. This thing here will be positive. So glancing at this, we can see that this is always going to be positive. And then as n moves from 1 to infinity, this will always be positive. And then factorial, that will always be positive. N is always positive. To the power of something that's positive, it will always be positive. So this absolute thing is irrelevant. So we can just discard the apps. So that will then take us to here. So when you get to this stage here, have a quick glance. It turns out that the absolute is useless. It's irrelevant because as you're moving from n to infinity, you're always positive anyway. So you can just discard the absolute sign. So that will then give you this. So now tidy this up. So you've got one fraction divided by another. So you've got one fraction divided by another is the same as u times in the reciprocal. So turn this upside down. That will then give you this. So now it's well, looking at this, this will simplify. Will cancel out with this thing here. Will simplify with this, because looking at this, you've got n factorial, you've got one notch higher, n plus 1. N plus 1 is one notch higher than n. That's like me giving you this. So this is your n here, this is your n plus 1. So you can see that they cancel out, leaving you with n plus 1. So the point here is that this thing here it will simplify to n plus 1. So this is your n plus 1 here. So this is your n plus 1. The point is that this will simplify with this to become this, and then leave this the same, and then leave this the same. So now looking at this, looking at this here. Remember, if you have something to the power of n plus 1 to the power of n plus 1, that's the same as you having the bubble to the power of n times the bubble to the power of 1. So this thing here, we can write it as this. So looking at this here, n plus 1, we can write it as n plus 1 to the power of n times n plus 1 to the power of 1. And then looking at this will cancel out with this. So these two will cancel out with each other. So hang on, we can rewrite this as this. These two will stay the same. So now this will cancel out with this, leaving you with this, leaving you with this. So now remember, if you have let's say x over y to the power of n, that's the same as x to the power of n over y to the power of n. So when you get to this stage here, you can rewrite it as this. So you can rewrite this thing here as n over n plus 1 to the power of n. So rewrite this as this. So we wanted to determine if our series will converge will converge or if it will diverge. We needed to look at an plus 1 divided by an, take the apps, and then it turns out to be this. Now we need to find the limit of this. We need to find out the limit of this. But as it turns out, you see, so you've got one thing to the power of another thing. So here you've got one thing to the power of another thing. This thing here wants to head towards 0. This thing here wants to head towards 0. This thing here wants to head towards infinity. So you've got 1 to the power of infinity. You've got a bubble to the power of another bubble. But this bubble here wants to head towards 1. This bubble here wants to get bigger and bigger and bigger. You see, this is an indeterminate form. This is an indeterminate form. If I were to give you something like this, 1 to the power of infinity, this will be 1. But then if I give you 1 to the power of, let's say, just a notch higher than 1, let's say 3 to the power of infinity, then this will head towards infinity. It will head towards infinity. So here you've got something that wants to head towards 1, and then to the power of something that wants to head towards infinity. As it turns out, this is indeterminate. We need a way of evaluating this. We can't. You see, if you have something like 1 to the power, sorry, 1.03 to the power of something that will get bigger and bigger to infinity, then you can conclude that this will head towards infinity. But the thing is, you've got one thing, you've got a thing that wants to head towards 1, and then you've got another thing that wants to head towards infinity. We need a way of evaluating this. This here at the moment, as it stands, is indeterminate. So I will continue in the next video. We cannot conclude that it's going to be. We cannot conclude that it's going to be. We cannot say that this is going to head towards 1 and then this will head towards infinity. We can't do that because here you've got this thing here that wants to head towards 1, and then this thing here wants to get bigger and bigger. We can't determine yet. I will continue in the next video.